Hello everyone! Today, we're diving into a critical intersection of insurance and artificial intelligence. INS-MMBench, the first comprehensive benchmark designed to test large vision language models in the insurance field. Let's start with a real-world scenario. When a car accident leads to an insurance claim, how do we quickly identify damaged parts, assess severity, and reach a fair claim decision? Or when a health check report includes results from breast ultrasounds, liver function tests, and EB virus screenings, how do we extract key info to evaluate an applicant's health risk? These are typical multimodal tasks in insurance, and they're exactly what we aim to address with ILVs. First, let's understand why multimodal technology matters so much for insurance. The insurance workflow, from underwriting to claims settlement, is filled with tasks that demand integrating multiple data types, text like policy documents or medical reports, numbers such as mileage or test values, and visuals like accident photos or X-rays. For example, in property insurance, assessing if a venue's conditions qualify for coverage requires analyzing both on-site images and written risk profiles. In practice, these tasks still rely heavily on manual work, slow, labor-intensive, and prone to human error. But the rise of ILVs offers a game-changing opportunity to streamline these processes, improve accuracy, and reduce manual intervention. Now, let's introduce the core of our work in INS-MMBench, built by our team from Fudan University's Department of Insurance and Risk Management. It's the first benchmark that systematically evaluates ILVs in insurance. Here's what makes it comprehensive. Coverage of insurance types. It spans 4 key insurance categories: auto, property, health, and agricultural insurance, covering the most representative areas of the industry. End-to-end business stages. We don't just test isolated steps. We include critical stages like risk underwriting, risk monitoring, and claims processing, aligning with real insurance workflows. Rich data and task layers. INS-MMBench includes 12,052 images and 10,372 questions, organized into 5 scenario tasks, 12 meta tasks, and 22 basic tasks. For example, a basic task might be recognizing a car's license plate, while a scenario task could be making a final auto insurance claim decision requiring multi-step reasoning. Broad model evaluation. We tested 11 models, both open source and closed source, to give a full picture of ILV's performance. To build this benchmark, we followed a rigorous insurance-specific approach. For task design, we used a bottom-up hierarchical method based on the insurance value chain. Take auto insurance as an example. First, we identified 3 key stages: vehicle underwriting, risk monitoring, and claims processing. Then, we pinpointed core visual elements like license plates or vehicle status and defined basic tasks. For example, license plate recognition, driving behavior detection. Finally, we combined these basic tasks into meta tasks and scenario tasks, creating a logical framework that mirrors real work. For data processing, we sourced high-adaptability datasets from platforms like Google, Kaggle, and GitHub, then refined them for insurance scenarios. We used a mix of hierarchical and random sampling to ensure balanced labels and diverse samples. When creating questions, we kept it practical. For simple tasks, we used dataset labels directly. For complex ones, we leveraged GPT-4o to generate realistic distractor options, making multiple choice questions that reflect real insurance challenges. Now, let's look at the key results from our evaluations. They hold valuable insights for how ILVs can and can't be used in insurance. First, GPT-4o leads but has limits. It outperforms all other models, with an overall accuracy of 69, 70, and even 86% in auto insurance. But here's the catch: most ILVs, including GPT-4o, still fall short of human baselines. For example, in agricultural insurance, GPT-4o only scores 36.38%, well below the human baseline of 42.5%. This means LVLMs are best used as auxiliary tools right now, not replacements for human experts. Second, performance varies by task and insurance type. LVLMs shine in auto and health insurance, especially in visual perception tasks. For instance, GPT-4o scores 98.5% in vehicle appearance recognition and 95.72% in health risk monitoring, but they struggle with knowledge-intensive reasoning like property risk assessment or agricultural crop damage detection. This tells us deploy LVLMs in phases, focusing on their strengths first. Third, complex scenarios challenge reasoning. Few tasks involving multi-step reasoning hit over 80% accuracy. Take auto insurance claim decisions. The final decision's average deviation diff for GPT-4o is 3,686.32, showing it can't yet match human precision in complex judgments. To fix this, we need more insurance-specific datasets and reinforcement. Learning tailored to industry needs. Fourth, the open source vs. closed source gap is narrowing. Models like LVLMs with 65.33% overall accuracy are approaching closed source performance. This is great news for insurers. It lowers barriers to AI adoption, letting companies build custom, domain-specific models without relying solely on closed source tools. We also dug into why LVLMs make mistakes. Our error analysis showed the top issue: lack of insurance expertise and reasoning skills, accounting for over 40% of errors in models like LVLMs. Other errors come from perception mistakes or failing to follow instructions. So, we tested solutions like enhancing prompts with insurance context. Looking ahead, how do we make LVLMs better for insurance? We have 3 key suggestions. Boost domain knowledge, build a dedicated insurance knowledge base and use transfer learning to embed industry expertise into models. Optimize reasoning, integrate knowledge graphs and multitask learning to enhance logical reasoning for complex tasks like risk assessment. Refine prompt design, create precise, insurance-specific prompts to align model logic with real business needs without overcomplicating inputs. In conclusion, INS-MMBench isn't just a benchmark, it's a roadmap. It shows where LVLMs can add value today: auto insurance visual checks, health risk monitoring, and where they need to improve tomorrow. The future of insurance AI isn't about replacing humans, it's about pairing human expertise with LVLMs efficiency. Thank you for your attention.